ladies and gentlemen, very welcome to join us. So on behalf of the Ministry of Environment Japan and the Asian Center for Apple Research, ACAP, so we would like to warmly invite, welcome all of you to join our session, the Next Generation Monitoring and Assessment System for Air Pollution in East Asia. So this session will give a present overview of the ongoing academic initiatives and also the showcase of private sector technologies in supporting the implementation in developing countries. And we can illustrate the way, the pathway to the next generation of air pollution monitoring and also assessment system in Asia. So today's session will include two parts. The section one, the part one, will be introduce the concept of the establishment in the next generation monitoring and assessment system for air pollution in East Asia, presented by researchers. And section two will be show the technique solution and monitoring and also climate change provided by the private sectors. So my name is Mingqun Huo. I'm a Chief Senior Researcher of ACAP. Today is my great honor to serve as the moderator for this session. So, and because actually we have very limited time, so we will not have the question and answer in this session, but we will invite all of you to join our coconut reception. And in that reception, please, we have a future discussion and questions. So the cocktail reception hosted by the MOEJ and ACAP will start immediately after this session finish. And will be in the exhibition space in the level 2, I think upstairs of here. Yeah, we warmly invite all of you to join. And now I will invite Mr. Tomoyuki Izumi, Director of Environmental Management Division, International Cooperation Bureau, Ministry of Environment Japan, to deliver a welcome remarks. Yeah, Mr. Izumi, onegaishimasu.
Good afternoon, distinguished colleagues. On behalf of the Ministry of the Environment Japan, it is my great pleasure to welcome you to this session, Next Generation Monitoring and Assessment System for Air Pollution in East Asia, jointly organized with the Asia Center for Air Pollution Research, ACAP. Air pollution remains one of the most pressing environmental challenges in our region, while we have seen encouraging progress in parts of Northeast Asia. Air pollution continues to affect human health, economic development, and climate resilience across the border Asian region, often beyond national borders. Addressing this challenge requires more than isolated efforts. It requires reliable data, shared understanding, and coordinated action across countries. In this context, robust monitoring and assessment systems form the foundation of effective air quality policy. Today's session focuses on how we can build next-generation monitoring and assessment systems by integrate satellite data, high-precision monitoring, and low-cost sensors, while also ensuring sustainable financing and practical deployment on the ground. Japan has long worked closely with ACAP and regional partners to strengthen scientific cooperation and policy-relevant knowledge on air pollution. We believe that combining public mechanisms such as the Joint Crediting Mechanism, JCM, with private sector innovation can accelerate the introduction of advanced, cost-effective solutions in the region. This session brings together researchers, policymakers, and industry leaders to share concrete experiences and explore pathways towards scalable and sustainable solutions for Asia. I hope today's discussions will contribute to stronger regional cooperation and actionable outcomes toward cleaner air for all. Thank you very much, and I wish you a productive session.
Yeah, thank you very much, Mr. Izumi, for your welcome remark. So now we will now start the first sector, first part of this session, the establishment of next generation monitoring and assessment system for air pollution in East Asia. So I will introduce three panelist researchers, and then we will start this session. So the first researcher is Dr. Hiroyuki Sase, head of the Ecological Impact Research Department and ACAP. And next speaker is Dr. Isamu Molino, head Satellite Remote Sensing Research Section, Earth System Division, National Institute for Environmental Studies. And third speaker is Dr. Aki Yuba, senior researcher at the Center for Air Pollution Research. Yeah, so and about this session will be moderated by the Dr. Sase. So yeah, Dr. Sase, please, it's your time. Dr. Floor is yours. Thank you very much.
Thank you. Thank you, Dr. Fu, for your introduction. My name is Hiroyuki Sase from the Ecological Impact Research Department, Asia Center for Air Pollution Research, which is designated as a network center for the acid deposition monitoring network in East Asia. I will serve as a moderator for this first part. In this section, I will begin by briefly explaining the concept of establishment of the next generation monitoring and assessment system for air pollution in East Asia. Following my presentation, two researchers, Dr. Isamu Molino from National Institute for Environmental Studies, Japan, and Dr. Aki Yuba, my colleague from Asia Center for Air Pollution Research, will present their research output. And then a panel discussion will then take place after this presentation. So I will now begin my presentation. Okay, today I would like to talk about the concept of next generation monitoring and assessment system for air pollution. So for the air pollution monitoring, well-structured monitoring assessment systems are essential for comprehensively understanding the current situation and evaluating future risks. So currently, in addition to conventional monitoring instruments, emerging technologies such as satellite observations and low-cost sensors offer a new opportunity to obtain spatio-temporally diverse data. So this presentation introduced the concept of next generation monitoring and assessment system for air pollution. Here you can see the image of air pollution management system. Based on the monitoring, assessment will be done, and then policy making will be considered, and then the policy implementation will be feedback to the monitoring activities. And then to support this process, the system as a system tools, in addition to monitoring activities, chemical transport model or emission inventories, and then inverse modeling combining the tools can be considered. And then we can assess the actual situation of the air pollution in the region. Next, please. Yeah, so far, ground-based monitoring has been conducted to obtain continuous high time resolution hourly data for gaseous and particulate matters. But the ground monitoring station have a little bit limitation. In addition to initial cost of setting up such a station, these monitors also require regular maintenance, including calibration. Therefore, it's challenging to increase the number of monitoring stations and even to maintain the existing ones. Next, please. So we consider to utilize the new technologies such as satellite observations, which will be introduced by the next speaker, Dr. Morino. Then, next please. Low-cost sensors, which will be introduced by my colleague, Dr. Akie Yuba, the third speaker. Then please. Then the monitoring data and the modeling data, modeling tools, we work together to assess the actual monitoring, actual situation of the air pollution in the region. So linkage between monitoring and modeling enables the integration of spatial or temporary diverse data. And it's very essential for providing useful information for policy decision making. So the monitoring and modeling should work together. Next, please. And this is one of the example measurement model fusion. The modeling and the monitoring data will work together. And then next, please. Next, please. Sorry, time is very, very limited. And then the next, please. Yes, this is the last slide I would like to show you. So these tools should work together. Next, please. So the point is how to integrate these tools and the data. And then based on this integration, we can consider some more comprehensive methods to assess the air pollution situation in the region, and which will be which will contribute to the policy making consideration. Thank you very much. And the next, I would like to invite Dr. Morino, Dr. Isamu Morino, head of Satellite Remote Sensing Research Section at the National Institute for Environmental Studies. Dr. Morino, the floor is yours.
Hi, my name is Morino from National Institute of Environmental Studies. Thank you very much. Very good opportunity showing our satellite project. Okay, my name is Morino here, and in this project there is a lot of the colleagues work join this project. Also support of the Ministry of Environment Japan. Okay. Next. Okay, this is an example of the satellite observation using tropomi. Probably, as you know, tropomi is a very famous satellite operated by ESA, and this is a map of the NO2 in troposphere. So as you can see, especially there is some high value. Oh, no. Okay, sorry. Like China, China and Europe and USA. So this is a very good and strong tool for understanding the air pollution. And as you know, recently, especially European people using this data, but probably I want to introduce this data for the especially Asian countries. Okay, next please. And this is also another example of the satellite observation by tropomi NO2, and this is very famous map, and left panel shows the before COVID pandemic, and this map in China, due to some big transport, there is high value on NO2 like this. But after that, during the COVID pandemic lockdown, there is almost very small value of the NO2. According to this, we can see the powerful tool of the satellite data. Next, please. Okay. This is some component of the measurement method. Left show the ground-based measurement, and this data, ground-based data mainly except in Japan. There is 1,000 sites of site like this, but as you know, there is still area without observation. So satellite data can cover this like this. And difference is in case of satellite, we measure the carbon amount like this. But surface measurement only value until the PBL, under PBL, boundary layer. Thank you very much. Okay. So this is the difference of the measurement, each other. Please. And already this Hase-san showed, but this is another some concept of the measurement and policy decision. And so recently we measuring satellite data and graph data. This data go to the chemotransport model, and after that we could get the emission data. And also, as you know, from ground-based data, we detect the information related to the human exposure, and using this, you can use this data to the politics. This is some concept of the how to use the observation data to the politics. Okay, next please. And this is another example of the satellite observation. This method we are using a bit special method. So especially in case of the tropomi, footprint is 5 kilometers, 7 kilometers. But by using over sampling method, we can get the more high spatial resolution data like this. And this data already we can get the data from the Medium Space Agency webpage. Okay, next please. So from this, I want to show our satellite project. Next please. In Japan, we operate in the 3 satellites. First is the GOSAT, and second GOSAT2, and now GOSAT GW. And all 3 satellites are in operation now. Next, please. And already I showed the first one is the GOSAT, more than 70 years old, and still this satellite is in operation. And mainly we are observing CO2 and methane. And as for the GOSAT, we operating from the 5 years ago, and from that we adding the CO band of the observation. Then we changed to the GOSAT GW from last year. We adding changed to the this is some FTS path measurement, and from that GOSAT GW we changed to the imaging measurement like this, and also we adding the NOs. As you know very well, so now our GHG research also connecting the air pollution. Especially we need a indicator of the human activity in order to separate the emission of the GHG. Next, please. This is a launch of portable launch GOSAT GW. This is very almost midnight from the 29th of the June. Next, please. And in the GOSAT GW, we have 2 observation modes like this. Left panel shows the wide mode, and swath in the almost 1,000 kilometers like this, and footprint is 10 kilometers. This value almost similar to the tropomi, but this information now is not enough for the our study. So we also install the focus mode, and in this case, target area becomes very small, like 19 kilometers, 9 kilometers, but we can select the 1 kilometer, 3 kilometer footprint. It's very powerful tool for the understanding the air pollution. Okay. This is some example of the wide mono data of using GOSAT data, GOSAT GW, just simulation. In case of the XCO2 is like this, and this is methane, and in case of the NO2, vertical column density. So as you know, so there is a clear value where there is some air pollution. Next, please. And this is another example of the detection of the NO2 emission power plant. This is the Tokyo Bay Area like this. And this is also simulation WAF. And this also trans-3D simulator. So we can see the some high value of the NO2. This area is this point is the power plant, and due to the northern wind, so NO2 value NO2 go to down like this. Okay, next please. This is very important. This is the first light observation using GOSAT GW. This is the wide mode measurement. As you can see, using wide mode, we can cover the all data all over the world like this. Next, please. This is an example of the wide mode observation. So this is the country area in Japan. So using this wide focus mode observation, we can cover the Tokyo down megacity area like this. Next, please. This is also first result of the retrieval from the GOSAT GW data, and left panel shows the CO2. This area is Los Angeles region, US. And mainly is the methane, and right is the NO2. As you can see, in fact, there is the two power plant like this. And at that time, window is go to the southeast like this. So we can see clear enhancement by the power plant like this. So this shows our GOSAT GW data can use some application of the air pollution. Next, please. But for satellite application, and so validation and verification of the data from satellite is very important. So we also do use the ground-based data set like EM27 for measuring CO2 and methane and carbon monoxide. Okay, and for NO2 as a molecule, we use the Pandora like this. Okay, next please. And for as of the GOSAT validation activity, we started some dense measurement of the portable FTS like this. And in this site, also we installed the Pandora measurement like this. Using this data, we validate the GOSAT GW, NO2, and other GHG molecule like this. Next, please. And this is an example of the 1 year measurement, 2 years measurement of the GHG measure over the country area. Yes, please. Okay. So we can focus someday. This is almost there is no enhancement due to the strong wind of the southwest. Next, please. This is an example of the we can get the enhancement by the so some southwest wind. This area is there are a lot of the factory and power plant like this. So you can see enhancement in the CO2 and methane like a CO. Of course, we can get the good data of high value of the NO2 also. Next, please. Finally, also we have started a new project of the India ground-based FTS project. Unfortunately, in India, we can get the free data set of the CO2 and methane data set. So that's very important of the one of the GOSAT GW validation activity. So last month, we installed the new FTS in the Kolkata like this. This is the TCON standard FTS. And next, we also installed the Bhopal. Next, please. This is an example of the TCON protocol measurement like this. From this, we can get the NO2, CO2, methane, and CO data. And next, please. From this, we can get the from spectra we can get the CO2 and methane. Also, we have planned to install this site as a NO Pandora for measuring NO2. So this is now this project very just starting. We are very exciting. So if you are interested, please tell me. Thank you very much.
Thank you, thank you, thank you, Doctor. Thank you, Dr. Morino, for your presentation. Yeah, very comprehensive idea for the satellite monitoring. And then next, I would like to invite Dr. Yuba, senior researcher of ACAP.
Hi, my name is Aki Yuba. Thank you for giving me this opportunity. I would like to focus on the local sensor monitoring in ENet. Next, please. So recently, the technology of local sensor has been improved rapidly. Local sensor is small and easy to install elsewhere in the reasonable price. It means that many LCS can be installed densely, and we can expand the monitoring coverage and reveal the fine scale spatial distribution and support to identify the urban hotspot. LCS has a big benefit on air quality monitoring. The concern on the precision and accuracy has been remained. So we suggest a hybrid air quality monitoring network. We call it HACMON, where LCS integrate use with a conventional monitor, reference grade monitor. HACMON can extend the monitoring coverage within the limited budget and human resources. Next, please. ENet also has a huge demand of using LCS, but we don't have not so much technical knowledge and methodology to make use of LCS in air quality monitoring. So we start LCS technical project and the ENet project fund. Next, please. It includes a demonstration of HACMON concept, development of the technical manuals, and guideline and capacity building. Some of them were implemented with a collaboration with ADB Technical Assistant Project. Next, please. Next, please. In the demonstration, we collocate LCS and reference grade monitor to check the performance of LCS and check the necessity of data collection. Next, please. We selected two cities. One is a big city, Yangon, and the other is one of the local city, Harbin. Next, please. This is a case of Yangon. We installed the Japanese LCS by Greenblue, and we also use a reference grade monitor manufactured by Horiba. Next, please. This is a case of Harbin. We installed a PM2.5 sensor here, and the sensor unit was developed at Nagoya University and Panasonic. Next, please. So we can know the PM2.5 ozone and meteorological parameter very high time resolution. So you can know the relationship between the wind direction and the PM2.5 concentration. You can know the wind comes from the southern part. Here is the city center, so the PM2.5 concentration a little bit higher. And next, please. Here is in the case of Harbin, PM2.5 concentration higher in the beginning of the monitoring. All 5 stations has a bit high concentration. It means the air pollution affected whole this region, not only the one spot. Next, please. And the next, please. So we get to the technical knowledge. So then we developed and published a guideline and manuals for LCS. You can download them in the VNet website. Please visit there. And the guideline is useful to plan the HACMON network itself. And the LCS manual helps the practitioners to install and maintain the LCS. So next, please. And next, please. To maximize the benefit of LCS, we should integrate the another type of monitoring data and technologies. So here shows the example, NASA developing a data fusion tool to visualize spatial temporal distribution of air pollutant. So it is based on LCS, difference grade monitor, and satellite and model simulation. That kind of things is very helpful for not only the citizens but also the policy makers. So next slide, please. So here's the summary. So time is so limited. So then I just showed this summary. Thank you so much.
Thank you, Dr. Yuba, for your presentation. So, please move to the center. So, we would like to move on to the panel discussion. So, this time I have prepared 2 questions for our panelists. In the next generation monitoring and assessment system, various tools and technologies are expected to be used together to obtain more comprehensive insight into air pollution. So the first question is, which tools or technologies do you consider most effective for creating synergy with your data? What types of the collaborations between tools or technologies do you anticipate? In the case of Dr. Morino, which tool is very important for your satellite data for collaboration?
Thank you very much. As you know, I already explained, satellite generate a lot of data set. But for the using the politics, verification of data is very important. Yes. So we started. We always sometimes we always doing a site project as well as ground-based tools development. So for satellite for the efficiency used for the satellite data, before that, ground truth verification is very important. So for me, easy to understand the some like a mapping, it's very easy. But for use variables, ground truth data also important. Now some importance is very also including for the ground data. Okay.
Yeah, thank you for your idea. How about Dr. Yuba? What is important for the LCS monitoring?
Okay, first for the LCS, the accuracy of LCS is not equal with conventional monitor, unfortunately. So it is essential to use LCS and difference grade monitor together, especially to validate the data and data collection, and also integrate use LCS and satellite is also very effective to understand the comprehensive air pollution especially in urban. So in urban area, the air pollution is consistent with regional air pollution, like long-range transport from the other area, and the local emission inside the city, like a vehicle emission or open waste burning or something. So then the dense Hackman identified the local emission and hotspot. Then satellite observation shows the very regional pollution. Then we merge it. Then when we find the very high concentration PM2.5 ozone in the urban area, we can know what percent comes from the local and what percent comes from the other transport.
Thank you. Thank you for your ideas. Yeah, actually, the various tool has very different advantages or disadvantages. So to cover such disadvantages, we need a collaboration and cooperation between the or integration of the various tools. And then the next question is collaboration with the collaboration with the private sector is essential for advancing air pollution monitoring and assessment in the region. What kind of tools, technologies, or services would you expect private sectors to develop?
Thank you very much. This question, already I showed, so now over the world, a lot of satellite operating, but so this satellite mainly operated by the European, US country, and China and Japan. And but gathering a lot of acknowledgement, so we can not watch the all data set. So if you have interest in watching this data, please get the data and make a mapping. And I want to ask some private sector this kind of watching something. And if you find something, so in this case, if there is some weak point related to the retrieval, we have to improve the retrieval algorithm. But if this is trust to this, it's a new finding. So probably this is a kind of the gold. So please do it. Start mining. So my request is that if your private company have interest in, please watch our data. And if you find something, please tell me. And we try to implement the data set. Also, we support your activities. Thank you.
Thank you. So for the aspect of LCS, I expected the equipment development and technology innovation for LCS. So recently there are many sensor units has developed, and also the local sensor assembles are also changing to day by day. And so I showed one example. So co-development of LCS sensor by university and private sector is one of the good example. So to collaboration with not only the private sector and also the academic field, it is also to accelerate the technology development. And also, I expected the tools and the apps for the visualization or open data platform. It is very useful to citizens to understand the current situation, as Dr. Morino said. That's
Yeah, thank you for your very wonderful ideas. As I mentioned in my presentation, the integration of various tools are very, very important. And then the technologies introduced in this session have a different characteristics, different time resolution and a different spatial resolution. And then, yeah, point is how to integrate such a different aspects. And then we can get more wider and also the clear views of their air pollution condition in the region if we can collaborate more actively. So I would like to close the first section. Thank you for your watching.
Thank you, Dr. Sase, Dr. Molino, and Dr. Yuba for the very wonderful talks. So now we will move to the second part of the session. So for the second part, we will show the technical solutions for the monitoring and also for the climate change actions provided by the private sectors. And so each company, please have a 5 minutes presentation, and because time is limited, so thank you very much for patience. So at first, I will invite the company for the technical solution of monitoring, yeah, to come to the panelists. Yeah, so the Mr. Joseph Deng from NVIDIA APAQ Group, and Mr. Toshihiko Daito, yeah, from Assistant Manager Marketing Department from Shimazu Corporations, and Mr. Chavapong Chetler Vanich, Energy Environment Strategy Office, Holiba Limitations, and Mr. Kazuhiro Misaka, Director in the Green Blue Corporations. Yeah, thank you very much. So at first, I will invite Joseph, Miss Joseph Deng. Yeah, please give a 5 minutes talk.
Hey, thank you, Dr. Hu. Good afternoon, distinguished guests from Japanese Ministry of Environment and also experts from ACAP. It's my huge pleasure to be here to share with you what we do as a private sector technology developer. So, okay. The title is Next Gen Monitoring and Assessment System for Air Pollution in East Asia. We all know that East Asia has made really great strides in terms of monitoring capability as well as research, including Japan, South Korea, and China, whereas Southeast Asia is where we are focusing on, and the technical capacity is still lagging and need to catch up. So next slide. I'll just introduce our team. So NVIDIA is a global company. NVIDIA established since 1980s in Europe. Our headquarters is in Paris, and now we have a research and development branch across Europe as well as in United States. Whereas our team here, I'm based in Singapore, and we have a small team in Singapore and in Jakarta, Indonesia, and we have joined NVIDIA since 2 years ago. So our team is entirely local and regional. Yeah. Next, please. And just to talk a few minutes about what NVIDIA is doing and preparing for the next generation of monitoring. So first of all, we are investing in AI capabilities for data validation. As you know, in developed countries, we have mature monitoring networks, right, operated for like over decades. And in France, we are like one of the leading contractor managing and operating the monitoring network in France for the reference stations. And over there, we have amassed like over 2 decades of monitoring data, over 300 million of data points across different parameters, and not only for our own instrument, but across different instruments like thermal, HORIBA, and you name it. Yeah. So we have next page. So basically, we have trained the AI model using the light GBM algorithm to simulate and to follow how scientists and the regulators would actually validate their data, including different statistical algorithms and how to limit the error and how to treat different anomalies, as well as identify like data trending issues. And so this is already a feature in our database management system for the NVIDIA's monitoring software. And after training this model, we have found that the success rate, basically compare AI model for data validation versus data validation, the success rate is around 93%. So there's only a 6% of differences. Yeah. And of course, we know that AI cannot entirely replace human for sure. And in our industry, especially, AI cannot replace real measurement. And we still focus very much on the measurement. And NVIDIA, as a global corporation, we are preparing for the next stage of monitoring, which is how to deal with like very complex air pollution and climate and public health interactions, like I heard many during this conference. So as an NVIDIA company, we provide integrated atmospheric observatory, or the next generation of super sites, focusing on studying the air pollution and climate interaction. So we have, of course, from our air models facility in Helsinki, we are developing like a particle size magnifier that can start measuring from 1 nanometer. And from the United States, our Colorado droplet team, we have the famous mini MPL LiDAR used by NASA scientists. And we have SB2 and the WEEPs for black carbon radiative forcing and also bioaerosol sensing and various based as well as airborne measurement. So that is one area we are still following very closely the frontier of science and try to develop alongside the scientists from the leading university from across the world. Next slide. So that basically sum up what we do. I've totally agree with experts just now mentioning about data integration and integrating different approaches to measurement, integrating different areas, different scientific domains, and as well as combining like data analysis using AI. So the future of measurement in our principle is, if monitoring principle is not correct, no data can compensate it. So basically combining real measurement, robust measurement technology with AI model is the way to go. Yeah, thank you.
Yeah, thank you very much for your very informative presentation. And now I would like to invite Mr. Daito from Shimazu. Yeah, please.
Hello, everyone. I'm sorry. My name is Daito from Shimazu Corporation. I will give you a brief introduction of Shimazu Corporation and our products. Since our company was founded in 1875, and we have been working on various social issues such as air pollution. Last year, we celebrated our 150th anniversary, and we will continue to support the creation of a carbon neutral society with advanced science and technology for a sustainable future. Next page, please. I will introduce you how our products contribute to Japan's air pollution problem. In Japan, from the 1970s to the 1960s, exhaust gas such as NOx and carbon dioxide emitted from thermal power plant and waste incineration plant were harmful for human health. Then regulation was enforced by Ministry of the Environment. To improve the air pollution, it is important to monitor the emission sources. We offer analyzers and solutions that can monitor the source of emissions. Next, please. This is the lineup that measures exhaust gas. There are two patterns of product groups depending on their use. The NSA model is online analyzer used in thermal power plants and waste incinerators. Sampling probe is inserted into a smoke stack and consistently monitoring the exhaust gas. The gas can be measured NOx, SOx, CO, CO2, and so on. On the other hand, the NOA, CZT, are portable analyzers that can be carried to the site. NOA is analyzing NOx, CZT is analyzing CO, and so on. These are used. I'm sorry. Next page, please. These are laboratory analytical instruments. PM 2.5 is a small particle with a particle size of 2.5 micrometer or less, floating in the atmosphere, and it is thought to have a significant impact on health. In Japan, environmental standards and laws for PM 2.5 were enforced in 2009, and local governments are monitoring them. For example, GCMS and LCMS, GCMS, HPLC are used for the measurement of VOCs, and EDX is used for measurement of inorganic components, and TOC is for total organic carbon. In addition to the atmosphere, our analyzers are used in various fields such as water quality, soil, and renewable energy. Recently, in the issue of PFOS contamination in tap water is making headlines. Our company provides the product that measures LCMS. Also, we supply a wide range of analytical instruments such as GCMS and so on. For measurement of marine microplastics, we have developed automated microplastic pre-treatment equipment. Also, many analyzers are used in water quality analysis in rivers and lakes. Next, please. Finally, I would like to introduce our local cooperation around the world. Our headquarters in Kyoto. We have research laboratories in sales office and sales offices such as Singapore, Germany, the United States, and China. We work together with partners around the world to solve social issues. That's all for my introduction. Thank you very much.
Okay. Thank you very much for your insightful presentations. So now may I invite Mr. Chavapong from Holiba to deliver presentation, please. Yeah.
Okay. Good afternoon, everyone. I'm representative from the Holiba, Thailand. So my name is Chavapong Chailavanit. You can call me Chu to be easier. I taking care about the industrial part and environmental part for the Thailand business. So next come. Actually, today I raised about the Horiba measurement technology that can contribute to air pollution control and carbon dioxide capture. First of all, for today event, I would like to let everyone understand Horiba, we are working together for the environmental, not just only the Thai or Japan. Right now, we are trying to cover about over the global right now. So next come. Horiba right now maybe more than 70 years from the established from the Kyoto. Right now we have the coverage of the staff every global already. Next up. Such as right now we still have the staff in the America, Europe, and Southeast Asia and Asia, and together with the Japan. Right now the ratio of the overseas staff may be less than increase around the 76% of our staff, because Horiba would like to support about the environmental monitoring to solve the emission problem right now. Next up. Basically, if you're talking about the air quality monitoring, everyone maybe know and understand that Horiba maybe contribute about this part maybe more than 50 years ago. So right now, if we're talking about the basic parameter, both of the NOx, SO2, carbon monoxide, carbon dioxide, or ozone, or hydrocarbon, maybe everyone understand already. Right now in Thai, we still have the very problem troubleshooting for the PM 2.5, PM 10. Next up. But for next one that we would like to promote and explain to anyone to understand. This is the new product that we use the X-ray fluorescence technology to find out what is the dust came from. So everyone will understand PM 2.5 just only dust, small dust, right? But how we know what is the dust came from? So that's why for this PX375, we use the X-ray fluorescence to monitoring about the element of the dust. So if we know what is the element of the dust, how do we use it? Next up. Basically, we will know about the PM 2.5, how much concentration in the air, right? But if we use together both of the X-ray and the dust PM 2.5, PM 10, maybe we will know the trend of the dust in that area, in that location. It means if we know what is the element came from that dust, we can specify that dust came from where. Such as for this case, we know that dust still consists about the zinc, arsenic, and the other parameter. So that's why we can classify that is maybe came from the coal combustion. Next up. Refer on that way. So if we maybe use the next generation of monitoring, maybe we install together with the wind direction. We know what is the that came from, together with the dust concentration, right? Next up. That's why this is the one of the feature that Horiba can provide to environmental, to the global, that we can do the fixed station or maybe mobile station together with the air pollution monitoring system and the X-ray monitoring system, and together with the air and wind the direction. That's mean not just only we know what concentration, we can know where it came from. So this is the next generation that the Horiba can contribute to help the environmental for the global. And not just only that, if we try to collect the data and send the data to maybe the data center, maybe we can collect much more the data and can try to tracking and maybe can do the model that we can find out what is, we can solve that problem again. Next up. So this is just only one part that Horiba will contribute, not just only the air pollution monitoring. This part maybe can help, we can solve the source of the problem again. So this is came from the Horiba Cup.
Yeah. Thank you very much for your sharing much interesting technologies. Yeah. So finally, I would like to invite Mr. Mr. Daito. Sorry. Monoto again. Mr. Misaka from Green Blue Company. Thank you.
Good afternoon. I'm Kazuhiro Misaka from Green Blue Corporation. It's a pleasure to be at the BAQ conference. Today, I'll introduce GBOT, our next generation system using high precision sensor to transform environmental monitoring. Next, please. Air pollution is a global crisis, but we lack reliable data. The barrier, conventional stations are too expensive and complex. We need high precision, low, easy. Easy operation at the same time. Our goal is to move from bulky station to dense flexible sensor grid. Next, please. GBOT is all-in-one solution, measuring PM 2.5 gases such as ozone and NO2 and weather data all at once. Its key strength is resilience. It automatically retransmits data after disruption and supports solar or USB PD. Most importantly, it's a reliable recurring R-squared value of 0.96 or higher against reference methods. We are also using AI calibration to reach reference goal method precision. Next. Yes. GBOT is already active in Myanmar, Vietnam, and Cambodia. In Yangon, we have established the know-how for data continuity despite infrastructure challenges. We are also innovating with mobile solution, integrating vehicle sensor and video to pinpoint traffic hotspot in real time. Our total solution combined resilient hardware with AI-powered dashboard. Next, please. Thank you for your attention.
Yeah, thank you very much for a very interesting talk for all the four private sectors for the monitoring part. So yeah, thank you very much. Yeah, please. Yeah. So now I would like to invite the private company for the climate change action, to provide technical solutions for climate change action. So first I will invite Mr. Ken Takahashi, Environmental Solution Sector from GFE Engineer Corporation. And please have a seat. Yeah, thank you. And next is Mr. Takahiro Inami, General Manager, EV Strategy Department from BMAC Corporations. And last is the Mr. Masahiro Nochi, Energy and Environmental Energy Environment Strategy Office from System Energy Service Corporations. So at first I would like to invite Mr. Takahashi from JFE to introduce. Thank you.
Thank you very much, Chair. Good afternoon. My name is Takahashi from JP Engineering Corporation. Maybe my title slide page, please. Because of time limitation. So until waiting some of my presentation, because of some time limitation, I only having some 5 minutes. Firstly, I'd like to say that my key message of my presentation, my message will be to tackle the air pollution, that we need to eliminate the source. And also the waste-related sources, the waste-to-energy process is a proven and reliable technology from our company. Next. JFE Engineering is one of some Japanese engineering, the infrastructure engineering companies. Almost half of our business is relating for the environment, such as some waste treatment or some wastewater treatment, renewable energy process, something like that. This experience makes us a strong partner in the Asian countries seeking practical solutions for the air quality and climate changes. Next, please. So now, let me guide you to the real world from this very beautiful conference room, okay? This is a very usual situation. Unfortunately, usual situation. This is some open dumping site, open waste dumping site. As you can see, smokes, the pollutions, odors maybe, water and air contamination. So that is a horrible and also the very hazardous situation in the, not only Asian countries, but also other countries as well. I'm sorry. So as I said in the first phase of this presentation, to solve this situation will be very much important. Next, please. So let me show you a real example. This our waste-to-energy facility in the Bac Ninh province in the Vietnam. We are processing 500 tons per day municipal solid waste and industrial solid waste. And also, we are very much saying thanks to the MOEJ to providing some JCM subsidy program. And also, we also are having some IFC's loan program from a World Bank Group. And also the important point is we are collaborating with a local waste management company in Vietnam. Next, please. So this is some very much business scheme. But as I explained, to having some very good financing scheme. Of course, we are very much proud of some technologies, but for implementation, the financing or some partnerships also very much important. Maybe my original voice is better here. The financing, partnership, technologies, is very important for some realistic implementation of this very important project as some waste energy process. But sometimes someone says Japanese technology expensive. Yes, maybe I can say, but benefit beyond the cost is also very much important. So of course, the first purpose of this waste energy process is for some processing for the waste. But on the other hand, for some good for some air quality management, climate change issues, and also urban benefit for the communities. So consideration this kind of figures, you can realize very best waste management or some climate change actions for your country, for your regions. Next, please. How to scale up this kind of process across regions. So, firstly, host countries' commitment is very much important because these kinds of waste processing facilities is one of some important civil service. So, host countries' commitment or local government people's commitment is very much important. Reliable technology partners. We JFE engineering is a very much proud of technologies, but long-term commitment is also very much important because waste management should operate for a longer time. Let's say, for example, 20 years, 25 years, safely and smoothly. Not only that for the very fast technology, but also long-term commitment is also very much important. And again, financial support. Without money, without financing scheme, we cannot materialize this kind of project. And also, I cannot get my salary, of course. Anyway, this financial support is also very much important. Next, please. This is my last presentation, right? So, I would like to conclude my presentation with my company purpose. Just for the earth. Do you remember my company name? JFE. Just for the earth. Okay? So please remember our company name. And also I'm very happy to have the discussion in some next networking session. Thank you very much.
Thank you very much for your very exciting talks. So now I will invite Itami-san from BMAC. Yeah, thank you.
Hi, good afternoon. I am Takahiro Inami from BMAC Corporation. Next page, please. Actually, we are manufacturing small size of EV with 3 wheelers, and our key component is vehicle control unit. VCU can contribute to the reduction of the air pollution, at the same time the climate action, especially in developing country. Our key message is electrification alone is not sufficient. Optimization determines impact. Next page, please. We are located in Imabari City in Shikoku Island. We are famous for the shipping industry. And our company belongs to shipping industry as well. And this is a picture of our headquarters. As you can find, this is with a unique design like a spaceship and became landmark in that area. And we have 3 main business core in our company. One is marine plant business. We produce the electric equipment for the big vessels. And utilizing those technology and know-how, we expand our business, industrial plant business, and the EV business as well. For the marine plant business, for those areas, we are achieving #1 market share more than for 10 years. We are manufacturing 3-wheel EV in Philippines, 30 kilometers southern part away from Manila, and starting year 2013. The background why we branch out Philippines is that the announcement of launching a project supported by Asia Development Bank, which they aim to convert 100,000 units from existing 3.5 million tricycle with a budget of $500 million. The tricycle is a kind of taxi which combines gas motorcycle and sidecars. Actually, we got awarded 3,000 units in the first bidding conducted in 2015. However, the rest of the succeeding bidding was all cancelled due to the transition of the government. Next, please. Through the deployment of 3,000 units by the project, the most pressing environment challenges are rapid urban air pollution from small commercial vehicles, limited charging infrastructure, cost-sensitive markets, limited maintenance capability, In such environments, simply introducing electric vehicle is not enough. If vehicles are insufficient, unsafe, or unreliable, adoption slow. Technology must maximize the efficiency and the reliability under constrained conditions. This is where VCU become critical. Next page, please. This is a comparison between a conventional EV system with a VCU and our systems. In a conventional EV system, motor control unit works independently. Battery monitoring system watch the battery independently without vehicle level optimization. With VMAC VCU, motor control, regenerative braking, charging optimization, battery protection, diagnostics are centrally managed. This allows historical control. Next, please. The biggest benefit for the VCU is the energy consumption. Instead of driving just approximately 6% gradient, our regenerative braking control improving driving range by up to 35%. We reduce battery production demand, resource extraction, life cycle CO2, total cost of ownership. Efficiency is climate action. Next, please. And the second critical issue is safety perception. Without centralized control, EV system react only after abnormality occurs. With VCU, continuous monitoring, preventive control, multi-layer protection, safety shift from reaction to prevention. Next, please. The third dimension is operational visibility. Our VCU enables data logging, remote diagnostics, battery condition monitoring, usage pattern analysis. This allows EV fleet to be operated as a managed assets. Next page, please. Originally developed for e-trikes, the same control architecture is now applied to industrial electric monorail, which can load heavy equipment and materials to the construction site in the mountain. E-rickshaw components in India and a golf cart conversion project. By using abundant I/O and high-performance architecture microcontrollers, the VCU platform supports versatile industrial mobility applications. Controller is scalable. Next page, please. I'll skip this page. Lastly, again, electrification reduces the emissions. Vehicle level optimization multiples the effect. VMAC VCU contribute to up to 35% efficiency improvement, preventive safety architecture, data-enabled fleet management. For the next phase of EV development in developing countries, control architecture is as important as electrification itself. Thank you for listening.
Yes, thank you very much. Yeah, and last but not least, I will invite Nochi-san to deliver a presentation.
Thank you. I'm last one. Okay, I need to do my time schedule. But don't worry, I have only one slide. So please focus on this. Okay. only this one. Okay. So thank you for giving us such a great opportunity. I appreciate everyone. So I hope this sharing information will be a good opportunity for us. So before, we had such a special monitoring company before. So we are VOC treatment system manufacturer. So this means I hope and I believe so we can collaborate together like a treatment system side and a monitoring side. So, actually, so we have 3 key points, but there are so many specialists in here. So we don't need to explain about point 1, about the VOC problem in here. So today I would like to focus on point 2. So this means effective use of resources. So I have one question. So when you go to the petrol station, so have you smelled the gasoline smell before? Maybe someone smelled like that. And this gasoline smell is one of VOCs. So what can we do is this VOC could be reused as a solvent. So this means, so when you feel the smell of the gasoline in gasoline stand or a petrol station, we can change, firstly, we reduce the gasoline smell around 5,000 ppm or less. And then we can recover as a VOC as a solvent. So this means, so we have experience to install our gasoline vapor unit in oil terminal. So in this case, so customer have received the gasoline 200,000 liter annually. How much is the cost? Maybe 200,000 US dollar annually. And so please calculate each on your currency. So this means, so our unit return on investment around 3 years. After that, so customer can receive their benefit. Yes, and then, so why we can do that? So this means we have one of special technology to using silica gel. So mainly, when we would like to treat the VOC, activated carbon is the mainly technology in the world. So, but silica gel is a non-flammable adsorbent. So this is one of our patent technology. We can treat such a flammable vapor. So, and then, so now we are trying to expanding our marketing network in the world. So firstly, Japan, China, Korea, and Thailand, Vietnam, Singapore, and recently Taiwan. And so we are trying to touch in India now. So if you have interested in our technology, so please have a question after this meeting. Thank you.
Thank you very much for the wonderful talk for all the private sectors. And due to everyone's very good collaborations now, so we have a little bit earlier schedule. So for this sector, so I would like to invite any, yes. Yeah, so please have a seat on the floor. Yeah, we have, well, here is one more seat, yeah. Maybe one or two more comments. Yeah, just one. Yeah. So I think this time is saved by you. So I will give this time for you. So, but yeah, please give me one or two sentences. Yeah, if you have additional more. Yeah, from you. Yeah, Mr. Deng. If you have more. Yeah, thank you.
Yeah, very happy to be here, and I found all the sharings very insightful. I think clean air, of course, is our vision and it's a shared commitment, right, across the government, regulators, our scientists, the researchers, as well as industries like us. And I'm also glad to see many solutions, right, working from different approaches, right, like monitoring, treatment, and of course, bigger infrastructure like waste incineration as well as electric vehicle. So I hope that all these applications will find its use in Asia and as well as in Southeast Asia. Thank you.
So from my opinion, I would like to thank you that it's been a Horiba can join for this event. And for me, I would like to hope, and I hope to this event is not just only this room. The result, the performance, the productivity, technology, or the other thing else, I hope everyone can bring it and can rediscuss again to bring the better condition for the global. Yeah.
The time is so limited. Shimazu Corporation. Sorry. Thank you very much. Anyway, that's all. Nothing special.
Today, I introduced GBIAT only. That's why I want to introduce our company, Green Blue. I belong to Green Blue company. Green Blue company is a research company, monitoring and research company. Today, I don't have enough time to introduce our company.
Thank you very much.
So anyway, thank you again for this very great opportunity to introduce our company and also our solutions as well. I'd like to say again that we must eliminate the source for the air pollution. Okay, and also please use our technology, waste energy technology from a JF Engine Corporation, and also please remember just for the us JFE. Thank you very much for this opportunity. Thank you.
Actually, we are looking for the partner in each Asian country. So please refer potential customer who is from a small EV manufacturer or electrification project. Thank you.
So at this time, I explained for using a gasoline vapor, but it's not only gasoline vapor, like a benzene, toluene, and monomer. So mainly so we can trace all over the VOCs, and J3 engines are also using our technology. So please remember the J3 engineering. Thank you.
Thank you very much for your quick thoughts. Yeah, thank you again for everyone. Yeah, please have a seat. Yeah, thank you very much. Yeah. So finally, I would like to invite Mrs. Ronggi-Yanang. Sorry, or actually, this is our co-worker, Deputy Director General of Asian Center for Airborne Research, to deliver the closing reflection and closing remark. Yeah, the floor is yours.
So thank you very much. First of all, I would like to thank all speakers, MOEJ, and also ACAP colleagues for this very wonderful section. So today we're talking about next generation, right? Monitoring for East Asia. So two keywords. Next generation, that means advanced technology, right? And we would need advanced technology from private sector because you can help us mobilize the environment, right? And another keyword is in East Asia. In East Asia, it still be a big gap. So I think with your support, we can close the gap. I see with my 30-year experience of working in this region, I see that the gap is, getting smaller and smaller. So I hope that one day we can close the gap, and then not just only to thinking about the monitoring and data, please thinking about how to utilize it, right? We monitor to a better quality, right? So we should think about how we're going to use it for policy driving, and then we can have healthier and cleaner air. Thank you very much. And today we have reception network, right? Maybe MC can announce later. Thank you very much and hope to see you again.
Thank you very much for joining us. And as we say, actually the cocktail reception party